after you've learned them the first time. A great example of this is using FOIL again, but only with full numbers. So for example, if I wanted to multiply 31 times 73, I could actually use FOIL in this case. I can first start with the first, 30 times 70, so that would give me 2100. I can then do the outer, which is 30 times 3. 30 times 3 is 90. I can do the inner, which is 70. And I can do the last, which is 3. If you add all of those together, you'll end up with 3, 6, 2, 2. And you can see how each one of the number systems added up together to give us that final digit. And you can see where we get each digit from just by using the colors. All right, so now you've learned that colors are very powerful within the mathematical system, and you can use it as a second dimension on top of what you're already dealing with. And the reason why I say an nth dimension is because you could actually do this with 3-dimensional objects and 4-dimensional objects and 5-dimensional. It is a separate dimension than the spatial dimensions that you're used to dealing with. Let's see how it's actually used in a lesson now. So here's a great example from my geometry class on how we actually use it in a real lesson. All right, so congratulations. You've now learned how to use color. So what does that actually look like when it comes to your lessons? This is a geometry lesson that I created a couple years ago for my students that deals with both proportions and sine, cosine, and tangent. And this is how I use color to teach what a sine, a cosine, and a tangent actually are in day-to-day life by using colors specifically. So the first thing I usually tell my students is to find the angle on your triangle. In this case, it is theta. And I usually give all of my students different highlighters. So they're given in 6 different colors. I have blue, I have pink/red, I have yellow, I have pink, I have purple, I have green, and I believe I have orange as well. It all depends on the day and which ones I have. So these are my main color palette that I use for my students. I first off tell them that red is the same thing as pink for their simplicity. So red is the same thing as pink, so let's go with that. First, we'll start with the opposite. This one we are going to want to color in with blue. If your students prefer specific colors for each type, you can do that in other types of lessons, but this lesson does require you to use specific colors to create the concepts that you'll see in a moment. We have the opposite directly across from the angle. We have the adjacent, which is right next door. I'm coloring my adjacent in with red. It's the second thing I'm doing. I'm also subtly integrating the idea that 1 is tied to the number blue, and 2 is tied to the number red, and 3 is tied to the number green, 4 is tied to the number yellow, 5 is for pink, 6 is for purple. You get the idea. I subtly add colors to numbers as associations. But for this in particular experiment, we're actually going to skip number 3 because we'll use it later on. And I'm going to jump straight into yellow/orange for hypotenuse. This one's specifically yellow, not orange, as that will come into play later. The next thing that you can do is, this is once again all behind the scenes while you're teaching, is you can color in details that connect things across the page. Notice I've just repeated the word hypotenuse in the student's mind without them actually realizing it. I've also repeated the word opposite and repeated the word adjacent by instantly highlighting it for them to highlight. They should be doing the exact same thing you're doing while you're up on the screen. You'll also notice that we can apply this same feature to the parts of our new triangle, as this could be our opposite, this could be our that could be our hypotenuse, this can be our opposite, and the adjacent will be down below. And this gives us now to the sine, cosine, and tangent. And this is really where the beautiful thing happens, is that because opposite we've colored in with blue, and hypotenuse we have colored in with yellow, what does blue plus yellow give you? Green. That's the same way a sign is. A sign, no matter the numbers and colors are, so let's say that this yellow over here was 13, and this blue over here was 5, we can say that this is 13 and 5. This thing is essentially the sign of this triangle. It is a ratio mixture of the two numbers or the two colors. You can have students think about the sign as just another name for a color. In the same way that blue and yellow together can be mixed to make green, in the same way blue and yellow can mix together to make green, so can the opposite and the hypotenuse mix together to create the sign. And this introduces a whole new layer of color theory. Students can see how sign is just a name for a combination between two things, just as the color green is a combination between the colors blue and the colors yellow. You can go on with this lesson and more details can come across. I can deal with proportions and talk about how you can use green to associate different parts of the thing. You can also use the same blue, and blue again, so you can create things that connect across different triangle areas without having to draw lines. And we talked about that a little bit earlier in the video. But the real catch is when it comes to something like this. So students can manually color this, but for most of the purposes, I like to have a pre-colored version for students, so that way they can see what I'm doing up on the screen and know what to color coordinate. So this is what the whole thing looks like if you color it. So you'll notice immediately we got some whole new interactions. It looks a lot brighter, it looks a lot better, and suddenly you automatically understand the connections between different points. Now, of course, you have to manually color this in on your worksheets that you build, but you get the idea. I mean, look how beautiful this is. This is really where it takes full advantage of everything. You'll notice over here that I have the sign as the name for the ratio between the hypotenuse and the opposite. This gives students the ability to actually spell the word and use the vocabulary in a sentence, but it also suddenly, once again, infers the coloring that they have to do. They have to assign colors to specific sections. And once again, they see that green, that orange, and that purple connection that they get with the sine, cosine, and tangent. I really like this purple effect because it's kind of a mixture between blue and purple, or I mean blue and red, which makes purple, and you can see that full connection. This also works for this section. You'll see that so, ka, toa. You could actually color these in with sine, cosine, and tangent right over here. And you can see how the students can understand that those are just names for the ratios rather than an actual new word, so to speak. Students often get confused with what's a tangent because it changes numbers every time. This, I think, gives a good definitive answer for what a tangent is. It's a ratio or a mixture between two things. Just like a mixture between two colors, it's a mixture between two numbers or two sides of a triangle. And it gives a great illustration on how to use this. So hopefully this helps you out when it comes to using color theory within your work and your worksheets for your students. And I hope this can help make your life a little bit more colorful. Thank you very much for listening. This is my capstone project for American Colleges of Education. My name is Alan, and thank you very much for listening.